All right, so here's a few examples to help you out with problem set number 1. Before we get started, the general idea of the problem sets is, yeah, they are going to be problems that are a little more challenging. Not always, but a little bit. More importantly, they're the problems that I think if you're taking calculus, you really need to be able to do these problems. For problem set number 1, what you need to be able to do is calculate limits, and then also determine, is the function continuous? And this right here is not a lecture section, this is just examples. So for example number 1, how about the limit as x approaches 5, the numerator is going to have x cubed minus 125, the denominator x minus 5. So whenever you have a limit, you should try substituting this number in and see what happens. Well, I can already see that if you substitute a 5 for x, it's going to cause division by 0. That means we need to do something else. And with these examples, I'm basically going to go through the different cases, and this case is you need to factor. So the numerator is the difference of cubes, because a 125 comes from 5 cubed. So use the difference of cubes formula, which is going to start off with x minus 5. When this is minus, this one starts off as minus. Then square the x. Now change the sign to plus. Multiply the 5 in the x, and then square the 5. And it's still divided by x minus 5. This x minus 5 is what's causing division by 0, and right here, these two cancel each other out. Now we can substitute the number 5 and get an actual answer. So that's going to be 5 squared plus 5 times 5 plus 25. So that would be a 25, and a 25. 3/4 makes 75 cents, so I believe that is 75. Then moving on to example number 2. What if it's a compound or a complex fraction? So you can either call it compound or complex. That would be an example like this. So the whole thing is a fraction. And then within that fraction, there are some more fractions. So as you can see, if you substituted 3, it's going to cause division by 0. So what I do is, for the x and the 3, these two denominators, the common denominator would be 3x. What I prefer to do is then take 3x, multiply it on the top, and multiply it on the bottom. Now the bottom part, you don't multiply it out. Because just like with this one, we're trying to get this thing to cancel. So we're trying to get this x minus 3 to cancel. So there's no reason to multiply out the bottom. Just leave it as parentheses, x minus 3 times 3x. But on the top, you do go ahead and multiply it out. So distribute. And this x right here and that x right there are going to cancel. All we have is 3. And then distribute, and this 3 and that 3 are going to cancel. So what's left is minus an x. And then, hopefully in algebra, somebody taught you x minus 3 and 3 minus x. They're very close to each other, except the signs are different. So you can cancel them and leave behind a -1. Or, to show your work, on the top, I could factor out a -1. That would make the x become positive and the 3 become negative. And at that point, x minus 3 and x minus 3 can cancel, so all that's left is a -1 over 3x. And now when I plug in this 3, it's not going to cause division by 0. So it leaves -1 over 3 times 3. aka negative 1 over 9. Then for example number 3, and this is the kind where you have to multiply it out. So find the limit as x approaches 4. And this one's going to be f of x minus f of 4 over x minus 4. This limit right here is actually finding what's called the derivative, and that is one of the most important ideas in calculus, the derivative. And that we'll be doing next week. Okay, then for the function f of x is equal to negative x squared plus 5x. So substitute the function itself right there. So it's going to look like the limit as x minus goes to 4. And then it's going to be negative x squared plus 5x. And then minus. And now we need to substitute a 4. So negative 4 squared plus 5 times 4, and that's divided by x minus 4. And I just realized that this one is not multiplied out. This one is actually factor it, which at first, or at least right now, it doesn't look like we're going to be able to factor it. But if it's set up in this form, we're going to be able to factor it. All right, the limit as x approaches 4. So the top has what? This is going to be 20. The negative is not inside parentheses, so you don't square it. So that means this is a positive 20 and this is a negative 16. So that's going to be 4, but then this negative applies. So it's going to be minus 4. Now, I don't know about you, but when I was taught to factor, I was taught to factor out this negative. Consequently, that's what I always do because that's what I'm used to. Which is analogous to, can I write with my left hand? Yes, actually I can. I'm not going to do it because it's very sloppy. But I was always taught, write with your right hand. Okay, since that's what I'm used to, that's what I'll do. Factor out a negative 1. It's going to leave x squared minus 5x plus 4. So change all of the signs in the numerator. Now, not only is this going to factor, but this right here is telling you one of the factors has to be x minus 4. So there's going to be a negative 1. I know that there has to be x minus 4. And then what else? So in order to get an x squared, I would need x. In order to get this last number to be a positive 4, that would have to be negative 4 times negative 1. And then make sure that the middle term works. This would be negative 4x, and this would be negative 1x, makes negative 5x. Yes, it works. And then, like always, this can cancel. And once those cancel, you can go ahead and substitute the number 4. So this is the point where you don't have to write the limit anymore. Once you're ready to substitute this number in. And so this will be 4 minus 1, so that's going to be 3, and times the negative 1 is negative 3. For example number 4, what if you use the conjugate? So that is needed for problems like this that have a square root. We'll go with the limit as x approaches 100. The bottom will have x minus 100. So that's what causes the division by 0. And then the top is going to be the square root of x minus 10. So the conjugate of this is going to be the square root of x plus 10. So whatever this symbol is right here, you use the opposite, and that is the conjugate. So the square root of x plus 10. And if you multiply the top, you need to multiply the bottom by the same thing. And the goal is to get this thing to cancel. So do not multiply out the denominator, leave that exactly as it is. Parentheses, x minus 100, and then parentheses, the square root, and plus a 10. And the good thing is when you multiply a conjugate, you only need to multiply the first one times the first one, which is going to be x, and the last one times the last one, which is going to be minus 100. So you don't have to do the middle terms because they're going to cancel. So these two would be negative 10 square root of x. These two would be positive 10 square root of x. They cancel, so we don't need to do that. The next thing is have these two cancel, leaving just a 1 on top. And then we're practically done. So there's a 1 on top, and now you could substitute the 100 right here for x. So that's going to be a 10 plus 10, which is 20. So the final answer is 1/20. Don't leave yet. We still have 2 more examples. Example number 5. And this is when you need to combine 2 fractions. So let's go with the limit as x approaches 0. The first fraction is going to be 1 over 2x squared plus 6x minus the other fraction is just 1 over x. And as you may have guessed, if you substitute a 0, that's going to cause division by 0. Aquí también. So we need to do algebra like get a common denominator. Well, before I can get a common denominator, I actually need to factor the first fraction. So let's see, factor this denominator. I could factor out a 2x from each one. Then it would leave x plus a 3. So that means that the common denominator has to have a 2, an x, and an x plus 3. This one has the x, but it's missing the 2, and it's missing the x plus 3. So multiply the top and the bottom by 2 and parentheses x plus 3. So now that we have a common denominator, you can write this as one fraction. The denominator will be the 2 times x plus 3. And then what is in the numerator? Well, there was already this 1, so there's a 1 minus, and then this minus and this 2, I'm going to go ahead and distribute that. So that's going to be negative 2 times x, and then negative 2 times 3, so that's going to be negative 6. And then what happens? So let's see, this is a positive 1 and a negative 6. So that's going to be negative 2x minus 5. And then it's over the common denominator, 2x times x minus 3. So with a 5 right here, I'm not going to be able to factor it. So then what do I do? Interesting. So what I think I'm going to do is I'm going to separate this into 2 fractions. So just like here, when you have two fractions and they have a common denominator, you could take those two fractions and make one fraction. Well, you could also go the other way around, and if you've got one fraction, you could separate it into two fractions. The reason I'm thinking that's a good idea is because I like how this 2x could cancel this 2x. But I can't do that right now, because if you're going to cancel a 2x, you have to cancel it here, and here, and here. And this doesn't have a 2x. So I'm going to separate it, so basically separate the numerator into two different parts. So we would have the negative 2x over 2x and x minus 3. And then we'd have the minus and 5 over 2x and x minus 3. And then over here, the 2x and the 2x can cancel, leaving a negative 1 on top. Over here, nothing cancels. But now I can see what's going on. So if you substitute a 0 in here, then that's just going to be a negative 3. And then this is going to be a negative 1 over a negative 3. So that part's done. That's going to be 1/3. And then what about this part? Well, since x is going to 0, this part doesn't really cause any trouble, but this is causing division by 0. So really what I need to do is look at this part. How much is 5 divided by 0? Now, in itself, 5 divided by 0 is not allowed. But if you look at the function y equals 5 over x, then that goes like this. And as x approaches 0, one side's going to go up to positive infinity, the other side's going to go down to negative infinity. An important rule with limits is the two sides have to agree. So the infinity part here is not really a problem. What the problem is one side's going up, one side's going down. So right here, they do not agree. So for this part, it does not exist. And so basically the answer is a 1/3 plus a does not exist means it does not exist. And then what about an example with continuous functions? Example number 6. Is f of x continuous? So in other words, it has no holes, no gaps, no jumps. This is a continuous function. Now that's not the example I was going to give, I just was playing around. So here's the function. So it's x squared minus 25 over x minus 5. And that's if x is not equal to 5. So for all other numbers, you can go ahead and use this as the function. And then it's going to equal 5 if x does equal 5. So basically we need to make sure that these two pieces match. So if I were to draw the graph of this function, and I don't have my graphing calculator with me, that's okay. But if I were to draw the graph of this, and let's say it goes like that, and then you get to where x is equal to 5. And because of this, which causes division by 0, there's going to be a hole in the graph. Okay, let's say the graph looks like that. And then you're supposed to plug in the number 5, 5. Well, let's say you plug that in and it goes like this. Well, then this did not fix the hole in the graph. So this is called a removable discontinuity. If you can plug in just one point and it removes the discontinuity, that's a removable discontinuity. If you put the dot in the wrong place, you didn't do a good job. So really that's what we're looking for. So this basically comes down to limits. So take the limit as x approaches 5. So I'm doing this part right now, but I'm doing it without a graphing calculator. So I'm taking the limit as x approaches 5 for x squared minus 25 over x minus 5. And then this becomes like one of the number 1, I think it was, where we have to factor. So factor the top, that's going to be x minus 5 times x plus 5. And then those two cancel. And once those two cancel, you can plug in the 5, and we'll get 5 plus 5, which is 10. Which means that the function is not continuous. So, by taking the limit as x approaches 5 and finding out that the answer was 10, so that means that the function looks something like this. It's going, it gets to right here, there's a hole in the graph, and then it keeps going. It's not a very accurate graph. The hole in the graph, that's the main point. So right now it's not continuous. But then me, in all of my wisdom, I said, well, why don't you put a point at 5, 5? So 5, 5 would go right there, right in the wrong spot. So that is not continuous. So if, when I made up the problem, I would have put a 10 here, then that would have put this dot right there and it would be continuous. But because I put a 5, that's not continuous.